Hello friends, this is Rashmi Singh and welcome to my channel Unraveling Science. Solutions for Atoms and Molecules, Class 9, Chapter 3. Questions inside the chapter. In a reaction, 5.3 grams of sodium carbonate reacted with 6 grams of acetic acid. The products were 2.2 grams of carbon dioxide and 0.9 grams of water and 8.2 grams of sodium acetate. Show that these observations are in agreement with the law of conservation of mass. So as you can see here, sodium carbonate plus acetic acid is sodium acetate plus carbon dioxide plus water. And we know that sodium carbonate is 5.3 grams, acetic acid 6 grams, sodium acetate is 8.2 grams, carbon dioxide 2.2 and water 0.9 grams. As per the law of conservation of mass, total mass of the reactants is equal to total mass of the products. As per the given reaction, 5.3 plus 6 is equals to 8.2 plus 2.2 plus 0.9, which is equals to 11.3 grams on both sides. Hence, the observations are in agreement with the law of conservation of mass. Hydrogen and oxygen combined in a ratio 1:8 by the mass to form water. What mass of oxygen gas would be required to react completely with 3 grams of hydrogen gas? We know that hydrogen and oxygen mix in the ratio of 1:8. For every 1 grams of hydrogen, there is 8 grams of oxygen. Therefore, for 3 grams of hydrogen, the quantity of oxygen will be 3 into 8, that is 24 grams. Therefore, 24 grams of oxygen gas would be required to react completely with 3 grams of hydrogen gas. Which postulates of Dalton's atomic theory is the result of the law of conservation of mass? The postulate of Dalton's atomic theory, which is the result of law of conservation of mass, is that atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Which postulates of Dalton's atomic theory can explain the law of definite proportions? The postulates of Dalton's atomic theory which explains the law of definite proportion is: atoms combined in a ratio of small whole numbers to form compound, and the relative numbers and the kinds of atoms are constant in a given compound. Define atomic mass unit. An atomic mass unit is the unit of mass used to express the weight of the atom and molecules, where one atomic mass is equal to 1/12 of the mass of one carbon atom. Why is it not possible to see an atom with the naked eyes? Atoms are too small to be seen with naked eyes. They are measured in nanometers. 1 meter is equals to 10 to the power 9 nanometer. Write down the formula of sodium oxide. So symbols are NaNO. Valency is 1 and 2. So crossing over, we get the formula Na2O. Similarly, for aluminum chloride, symbols are Al and Cl. Valencies are 3 and 1. Crossing over, we get formula AlCl3. For sodium sulfide, symbols Na and S. Valencies 1 and 2. We get the formula Na2S. For magnesium hydroxide, symbols MgOH, valency 2, 1, formula MgOH whole twice. Write down the names of compounds represented by the following formulae. This is aluminum sulfate, then calcium chloride, potassium sulfate, potassium nitrate, calcium carbonate. What is meant by the term chemical formula? A chemical formula is a symbolic representation of a chemical compound. It tells us about the number of atoms of an element present in the compound. For example, the chemical formula of sodium chloride is NaCl. It tells us that NaCl is composed of one atom of sodium and one atom of chlorine. How many atoms are present in a H2S molecule? It has 2 atoms of hydrogen and 1 atom of sulfur, total 3 atoms. For phosphate ion, has 1 atom of phosphorus, 4 atoms of oxygen, total 5 atoms. Calculate the molecular masses of first hydrogen. So 2 into atomic mass of hydrogen will be 2 into 1, that is 2 units. For oxygen, 2 into atomic mass of oxygen, that is 2 into 16, that is 32 units. Cl2, 2 into atomic mass of chlorine, that is 2 into 35.5, which is 71 units. Carbon dioxide, 1 into atomic mass of carbon plus 2 into atomic mass of oxygen. So that will be 1 into 12 plus 2 into 16, 44 units. CH4 methane, 1 into atomic mass of C plus 4 into atomic mass of H. Putting the values, we get 16 units. Similarly for C2H6, 2 into atomic mass of C plus 6 into atomic mass of H. That will be 2 into 12 plus 6 into 1, that is 30 units. C2H4, 2 into atomic mass of C plus 4 into atomic mass of H. Putting the values, we get 28 units. NH3, ammonia, 1 into atomic mass of N plus 3 into atomic mass of H. 1 into 14 plus 3 into 1, that is 17 units. CH3OH, 1 into atomic mass of C plus 4 into atomic mass of H plus 1 into atomic mass of oxygen, that is 1 into 12 plus 4 into 1 plus 1 into 16, that is 32 units. Calculate the formula unit masses of zinc oxide, sodium oxide, potassium carbonate. Given masses of zinc and sodium are given here. So formula unit masses of zinc oxide, it's given atomic mass of zinc plus atomic mass of O. So 65 plus 16, 81 units. For formula unit mass of sodium oxide, we know that sodium oxide atomic mass is 23, it's given here. So putting the values, we get 62 units. Similarly, formula unit mass of potassium carbonate, 2 into atomic mass of potassium plus 1 into atomic mass of carbon plus 3 into atomic mass of oxygen. Writing down the values, we get 138 units. If 1 mole of carbon atom weighs 12 grams, what is the mass in grams of 1 atom of carbon? Mass of 1 mole of carbon is equals to molar mass of carbon, which is equals to 12 grams, that is given here. We know that 1 mole of carbon is 6.022 into 10 to the power 23 atoms of carbon. Therefore, mass of 6.022 into 10 to the power 23 atoms of carbon is equals to 12 grams. So mass of 1 atom of carbon will be 12 grams upon 6.022 into 10 to the power 23, which will be equal to 1.99 into 10 to the power minus 23. Back exercises. 0.24 gram sample of a compound of oxygen and boron was found by analysis containing 0.096 grams of boron and 1.144 grams of oxygen. Calculate the percentage composition of compound by weight. So mass of boron is 0.098 grams, it's given. Mass of oxygen given is 0.144 grams. So mass of the sample is 0.24 grams, that is also given. Thus the percentage of boron by weight in the compound will be 0.096 upon 0.24 grams into 100, that will be equal to 40%. Similarly, the percentage of oxygen by weight in the compound will be 0.144 upon 0.24 into 100, that will equal to 60%. When 3 grams of carbon is burnt in 8 grams of oxygen, 11 grams of carbon dioxide is produced. What mass of carbon dioxide will be formed when 3 grams of carbon is burned in 50 grams of oxygen? Which law of chemical combination will give your answer? According to the laws of chemical combination of constant proportions, in a chemical compound, the elementary constituents always combined in a constant proportion by weight or mass. So C plus O2 will give you CO2. 1 mole of carbon, 12 grams, 1 mole of oxygen is 32 grams and 1 mole of carbon dioxide is 44 grams. It shows that 12 grams of carbon burnt in 32 grams of oxygen to give 44 grams of carbon dioxide. Therefore, 3 grams of carbon reacts with 8 grams of oxygen to form 11 grams of carbon dioxide, which is also given here. So, whether 3 grams of carbon is burnt in 8 grams of oxygen or in 50 grams of oxygen, in both cases only 11 grams of carbon dioxide will be formed, as the rest of 50 minus 8, 42 grams will remain unreactive. What is a polyatomic ion? Give examples. The ion which contain more than one atom, same kind or different kind, and behave as a single unit are called polyatomic ions. For example, ammonium ion, nitrate ion, sulfate ion, phosphate ion. Write the chemical formula of the following. First is magnesium chloride. So we know the symbol is Mg and Cl. Valencies are 2 and 1. So crossing over we get MgCl2. Second is calcium oxide. Symbol is CaNO. Valencies are 2 and 2. Crossing over we can write it as Ca2O2, or by reducing we can write as CaO. Similarly, for copper nitrate, symbols are Cu and NO3, valencies are 2 and 1. So formula will be CuNO3 whole twice. For aluminum chloride, Al and Cl, valencies 3 and 1. Formula will be AlCl3. For calcium carbonate, symbols CaCO3, valencies are both 2 and 2. So we get CaCO3. Give the names of the elements present in the following compounds: quicklime, hydrogen bromide, baking powder, potassium sulfate. So quicklime is also known as calcium oxide, which contains calcium and oxygen. Hydrogen bromide contains hydrogen and bromine. Baking soda is sodium bicarbonate, which contains sodium, hydrogen, carbon and oxygen. Potassium sulfate contains potassium, sulfur and oxygen. Calculate the molar mass of the following substances. Ethine, C2H2. We know that C is equals to 12 and H is equals to 1. So putting the values, we get 26 grams molar mass of ethine. Now for sulfur molecules, we know sulfur's mass is 32. So 8 into 32 is 256 grams. Similarly for phosphorus molecule, phosphorus mass is 31. So 4 into 31 will be 124 grams. For hydrogen chloride, mass of H is 1, Cl is 35.5. Putting the values, we get hydrogen chloride 36.5 grams mass. For nitric acid, we know H is equals to 1 N 14 O 16. So putting down the values, we get nitric acid mass is 63 grams. What is the mass of 1 mole of nitrogen atom? The mass of 1 mole of nitrogen atom is 14 grams. 4 moles of aluminum atom, atomic mass of aluminum is 27. So the mass of 4 moles of aluminum atoms will be 4 into 27, that is 108 grams. And 10 moles of sodium sulfide. So putting the values in the formula, the mass of 10 moles of sodium sulfide will be 10 into 2 into 23 plus 32 plus 3 into 16, that is 1260 grams. Convert into moles, 12 grams of oxygen gas. So mass of oxygen gas is 12 grams. Molar mass of oxygen is 2 into 16, that is 32 grams. So number of moles is equals to mass given upon the molar mass of oxygen. Now writing down the values, we get 0.375 moles. 20 grams of water. So given the mass of water is 20 gram, molar mass of water is 2 into mass of hydrogen plus mass of oxygen, that will be equal to 18 grams. So the number of moles will be equal to mass given upon molar mass of water. Writing down the values, we get 20 upon 18, that is 1.11 grams. 22 grams of carbon dioxide. Given mass of carbon dioxide is 22 grams, molar mass of carbon dioxide will be mass of carbon plus 2 into mass of oxygen. So putting the values, we get 44 grams. So number of moles will be, putting in the same formula, we get 22 upon 44, that will be equal to 0.5 mole. What is the mass of 0.2 mole of oxygen atom? So mass of 1 mole of oxygen atom is 16 grams. So mass of 0.2 moles will be 0.2 into 16, that is 3.2 grams. 0.5 moles of water molecules. So we know that the mass of 1 mole of water is 18 grams. So mass of 0.5 moles will be 0.5 into 18, that is 9 grams. Calculate the number of moles of sulfur S8 present in 16 grams of solid sulfur. Molecular mass of sulfur S8 is 8 into 32, 256 grams. Mass given here is 16 grams. So number of moles will be mass given upon molar mass of sulfur. So putting the values, we get 16 upon 256, which is equals to 0.0625 moles. Now number of molecules of sulfur will be equal to number of moles into Avogadro's number. Now writing down the values, we get 3.763 into 10 to the power 22 molecules. Calculate the number of aluminum ions present in 0.051 grams of aluminum oxide. The mass of ion is same as that of mass of atom of the same element. Atomic mass of aluminum is 27 units. So 1 mole of aluminum oxide will be 2 into 27 plus 3 into 16, that is 102 grams or 102 units we can say. So there are 2 aluminum ions present in the aluminum oxide, as you can see in the formula here. So 1 mole of aluminum oxide is 6.022 into 10 to the power 23 molecules of aluminum oxide. So 102 grams of aluminum oxide contains 2 into 10 6.022 10 into 10 to the power 23 aluminum ions. So for 0.051 grams of aluminum oxide will contain, writing down the formula, 2 into 6.022 into 10 to the power 23 into 0.051 upon 102, that will be equal to 6.022 into 10 to the power. Thanks for watching. Please do like, share and subscribe.